synthesis, docking studies. So this is the PDB ID that we have taken. These are the important amino acids in the active sites, and we found that there are two important amino acids which are responsible for the catalytic action, and the dimerization is also essential for the catalytic activity. And this protein, these amino acids, GLU290, arginine 4, arginine 290 are crucial for dimerization. If you block that, the dimerization process also can be blocked, and it can affect the catalytic activity. Again, the puromycin analogs were also identified from literature. Around 50 puromycin analogs were identified, and it is used to dock against peptidile tRNA hydrolase. Actually, it is a target protein in Mycobacterium tuberculosis. We know that it's, the multi-drug resistant strains are emerging, so there is a need for finding good medicines for that. So we targeted the PTH, and the main attraction is that this particular bacterial PTH has significant structural difference with the eukaryotic PTH, so it can be a good target against bacterial pathogens. Again, from a robotic study, it is very evident that the puromycin demonstrate a promising interaction with the Mycobacterium tuberculosis PTH. And this is the PDB IDs of the crystal structures that we have used in our docking studies. Then these are the softwares and databases used, and this is the flowchart of the docking process, and we have done docking using AutoDockLina. About the docking results, we have studied around 108 acetonucleoside analogs, its docking interaction, and these are the top scoring ligands. And here we have done a blind docking and active site docking. In blind docking, the docking score are quite high, and in active site docking, it is good, but it is lesser than that. Here we found that the guanosine-based nucleoside are having a high docking score, and with active site docking, the adenine-based molecules are showing good scores. So these are the two 2D interaction diagrams of these molecules. Then from this study, we got some insight that the guanosine nucleoside analogs are having top docking scores, indicating that this particular structure is giving more interaction with the protein. And also here the silo and ribo acyl forms when identified and checked, we found that its configuration, the silo-ribo configuration also significantly influenced the interaction pattern. Again, we checked the docking score of azithromycin, xylazithromycin, and xylazithromycin. These are the derivatives we have prepared, and we found that the thymine-based molecules are having a lower docking score compared to the adenosine-based molecules. About the docking results of puromycin analogs, these are the 50 puromycin analogs that we have studied. These are the top docking score ligands, and this is the 2D interaction pattern with 2Z2I crystal structure, and this is with the 7W36. And on analyzing, we found that the puromycin, and when it is compared with the adenosine-based xylopuromycin analog, they have the similar docking scores, but when this adenine group is replaced with thymine, the docking scores are reduced, interaction patterns are reduced. So let me summarize my chapter 3. We have studied the blind docking and active site docking interactions of SARS-CoV-2 main protease 6Y84 with the 108 acetonucleoside analogs, and guanine and adenosine-based nucleosides are found to have good docking score, suggesting strong binding affinity with the protein. And acetonucleoside analogs found to have good interaction with the amino acid residues, which are responsible for the dimerization process. And we have studied the docking interaction of 50 puromycin analogs with the peptidile tRNA hydrolase enzyme, 2Z2I and 7W36. The puromycin analogs were found to interact with the basic amino acid residues, which are responsible for this substrate binding and catalytic activity. The replacement of adenine base with thymine base actually reduced the docking score of puromycin analog. So as a future perspective, we aim to further investigate the pharmacologic features of azidonucleoside and furomycin alpha that may enhance their interaction with the antiviral and antibacterial drug targets. So I have a paper from my chapter 1 in Letters in Organic Chemistry, and these are some of the manuscripts under preparation. We haven't published papers based on chapter 2 and 3, so the manuscripts are under preparation. There are 2 oral presentation and 1 poster presentation based on this. And let me acknowledge my guide. Okay, okay, sir. Okay, sir.
So what is the next step for the Shanae? So actually, appreciate transition police from the audience. First, to the audience, please. We shall appreciate if we share some thoughts with us. To the audience.
Yeah, yes, sir. I can hear you.
Any question you receive from the audience? My colleagues doing something else. So yes, I'm going to do this it's a reflection of a really work. Let's correct. And you have taken a lot of natural rate. Basically, the normally follows the video. Then consciously, the overall considerations. So that's manifest. Did you begin to do police?
Yes, sir.
Somewhere if you are happy that some of the police will come out to your reservation. Still, I have some police which I will share with you. Okay. Scheme 20. Was that good before scheme 20? Was that good different approaches?
Yes, sir.
Related to quality game.
Yes, sir.
Inside there, what would be the reason for that?
Yes, sir. Sir, this one now is sir. Yes, sir. Yes, sir. Yes, sir. Actually,